We're going to talk about concentration, and I know it's not the type that we're mainly dealing with on trying to focus. When we deal with concentration, we're dealing with things that are generally in a liquid form. So that's what we'll deal with in honors chemistry. So in honors chemistry, we'll deal with concentration in liquid form. Now, we'll talk in AP about gases with concentration, but we're not going to worry about that today. Excuse me. I can't remember if they still sell these types of things. The orange juice that's in those tubes, it's frozen solid. They still make that? Or okay. That would be essentially concentrated, and if you take that orange block and put it in your pitcher and then add some water, then you are diluting it. Good. And generally speaking, whenever, at least when I was a kid and used to do that, I would dilute it more than the instructions said, just a little too sweet for me. But we'll talk about things that are dilute, things that are concentrated in this topic here. ppm and ppb, parts per million, parts per billion. This is mainly what the news or the newspapers would talk about in terms of concentration. Like there might be an article or a news story that says, in your drinking water, there might be acceptable levels of fecal matter around 14 ppm. Fecal matter? You don't know what fecal matter is? It's poop, yeah. So in other words, for every million particles of water, 14 of those is poop particles. Now wait. Now hold on. We gotta get rid of some misnotions here. How many in here like spring water? I love spring water. No, spring water. In other words, like Aquafina, Ice Mountain, things like that. So I'm not a big fan of Ice Mountain, but I love Aquafina. You want to know why I don't like Ice Mountain? Because I don't like the animals that live around wherever these streams are. The reason why water has flavor is because of the different animals that live in that region. So maybe if you like Ice Mountain, you like that particular brand of moose urine. Moose poop, that too. But water actually has no taste. So if you live in a place that has well water, I don't, but I hate going to a house that has well water because it just tastes terrible. Yeah, because it has all that stuff in there, okay? It's got sulfur. They have their septic system right next to the well, and it all filters in together and churns up. It's delicious.
You ever been to the right houses?
No, I've been to quite a few. But we will not talk about ppm and ppbs in here, okay? But just wanted to introduce that to you. What we will be talking about in here is molarity. Now, molarity is a very common term, and again, hopefully you notice that mole component in there. When we talk about molarity, we're talking about the number of moles that we have dissolved in our solvent, and that's always a volume. Now, you may have heard that water is the universal solvent and that it likes to dissolve things that are water soluble. In other words, a lot of things that we eat are dissolved in water. That way our body can digest it and break it down. In other words, we're not chucking marbles in our mouth and swallowing those down, hoping that that's going to be of some nutritional value. They're not soluble, so whatever marbles you put in, they're going to come out the exact same way later on. So unless you just like hearing a ting on the porcelain, don't eat marbles. Okay, just saying. So when we talk about molarity, and it can be abbreviated as big M. Now that's capital M. So one thing that we don't want to do is, like in our work, write big M inside of the molarity because again it's moles per liter. And we'll do some work with that. So molarity is what we will be talking about as chemists in terms of concentration. Okay. Let's see here. Also, this is a pretty good sticking point here, that when you look at the value, say like I had 2.25 molarity, the number always goes with the unit moles. Now, this is all you have to show is this right here. If I'm ever asking you to do a calculation, you don't have to put of solvent. But the number for the molarity always goes with the unit moles, and it's always going to be under 1 liter. And generally speaking, the way I would write this would be 2.25 moles for every liter. And notice I don't even put a number with the liter, but I do put the unit liter in that. Okay? Because normally we'll be doing something with that, which you'll find out here very shortly. Okay. Let's go back down. Here's a great rule. Okay. I really recommend this. So as a great rule, what happened? Here we go. If you know the volume, or if you're given the volume and the molarity, always, always, always start with the volume. Okay? If you're given the volume and the molarity, or you know the volume and the molarity, always start with the volume. Because generally speaking, we're going to be starting with the volume, and that will cancel out, leaving us with moles. And so when we are left with moles, we can do a lot of things. We can find out how many grams that is. We can find out how many particles that is. And that's our gateway for stoichiometry, which we'll talk about next topic. Not yet, but stoichiometry is. All right, so let's look at the practice problems. It's so much fun. So let's look at the first one. It says, how many moles of sulfuric acid are contained in a 3.5 liter of a 6.5 molar solution? So again, how many moles? That's what we're looking for, right? Do we know the volume and do we know the molarity? We don't know the volume? We don't? So we know the volume and we know the molarity, so start with the volume. Okay? And again, remember that 6.5, so 6.5 molar really means 6.5 moles per liter. So that's how I want to put that value into my factor labeling. So I'm going to put the 6.5 moles over liter. What you never ever want to do is put a capital M right there. Don't do it. I'm not even going to write it because I don't want you to write it down and go, why did he do that? Okay? So don't write a capital M because, again, the capital M represents moles divided by liters. And I don't want you to have the wrong units inside the word. Now, if I cancel off my liters, do I have the unit that I'm looking for? Yeah. So that means I'm done with that problem, right? So solve. So that's 22 point what? 75? And that's moles. Good. Okay, so 22.75. Everybody able to get that? That's easy, isn't it? Piece of cake. So let's look at another example, or another practice problem. Number 2 asks, what is the molarity of a solution that has 75 grams of calcium hydroxide dissolved in enough water so that the total volume is 3.5 liters? So the question wants to know, what is the molarity? So the question is asking you to determine the molarity. Now at the beginning here, you may wish to build it. In other words, find out how many moles you have first, and then determine how many liters you have, and then put that all together in one equation. And then I'll show you a shorter way of doing it. But can I take 75 grams? Is that in moles? No. So what do I need to do? Good. So just like what we did on the quiz, so we have 75 grams. And how do I write calcium hydroxide? Ca. Okay, so that's a -1. Calcium has what charge? 2. Good, so that means I need how many hydroxides? 2 of those. Okay, so that's good. So then we can say that we are looking for a mole, because again, that's what needs to go on top. So grams to moles, just like that same sequence still plays here. So calcium is 40.08 grams plus 2 oxygens plus 2 hydrogen, and what does that equal? I don't remember what that mole mass was. .74 was the molar mass. 74.096 grams, I believe. So if I do 70, is that right?
Yeah.
Okay. So it's, oh, okay. So that gives us 1.01, 22 moles. And again, we don't want to round that because that's not our final answer. So we can plug that into our number of moles. What is our volume here? 3.5 liters. Good. So we'll take that and plug it in. So 3.5. And that will give us our molarity. And again, don't forget that our unit for molarity is moles per liter, so whatever that equals. So I think it's like 0.289. Does that sound right? Okay. Now, that's the quote-unquote long way of doing it. In other words, finding out how many moles you have and then plugging it into the equation where you take moles divided by liters. If you want to put this all into one package, you can. In other words, if I put, say, my 3.5 liters here, what units cancel in this equation right up here? The grams, right? So the grams cancel out. So we're left with moles divided by liters, which is molarity. So if you were wanting to do that, that's fine. The way you would type that in would be 75 divided by, open up the parentheses, 3.5 times, open the parentheses for the molar mass, which is 40.08, plus 2 times 16, plus 2 times, times 1.008, and then close both parentheses, and you should get 0.289. Okay. So I don't care which way you do this, just as long as you're showing me the complete process. Okay. So if you're not comfortable with putting it all in one equation, then do what we did like before the quiz, where you took the grams, found out how many moles, boom, inserted that. Took your volume, boom, inserted that in. Okay. All right, so that's not too bad. So part of the homework, oh wait, no, sorry, I spoke too soon. Preparing solutions. Did you guys get the blanks for that? No. No, maybe not, okay. So I think enough. Which one's the blank? Are they both blanks?
Yeah.
Okay, good. And the reason why I had you put that in, because this is going to be your one opportunity throughout your whole honors chemistry career to write a sentence in your answer. Writing a sentence. In some cases it might even be a fragment, but that's okay. This is an English class, so I don't care. As long as you're getting the point across, I'm good.
So it's like a story problem.
It's like a story answer. Yeah. All right. Now, when preparing, and it'll probably be easier to explain it, when you're asked to give directions, now we did just a second ago, we calculated the molarity. However, if I say that I needed to find a certain number of moles, how could I measure moles out? Is there some device out there that likes to measure moles?
No, it's not a second.
Very good. But is there a device out there that could read the values underneath each element? What are the units for these numbers underneath?
Grams.
Grams. Is there something that can measure grams? There's like a scale. So we don't have a device that measures moles, but we definitely do have a device that measures grams. So in this case, where you're given the volume and the molarity, that'll tell us how many moles we have, but we need to go one more step and calculate how many grams. And that's what we're going to do. And if it says give directions, well, we'll get to that in a second. But do we know our volume and our molarity here? Yes. So we want to start with what? The volume. Very good. So we're going to go 3 liters. And it's a 1.5 molar solution, so 1.5 moles per liter. And if I stopped right there, I'd have my number of moles. But I don't know how to measure moles, so I'm going to go one more step. And I'm going to move my moles diagonally. So 1 mole of CuSO4, I gave you the formula for the copper 2 sulfate. So we need to find out the molar mass for copper 2 sulfate. And copper is 63. Thank you. And we have a sulfur, that's 32.06. And 4 oxygens. What happened? And I did notice this on the quiz. If I'm giving you the formula, you're good to go.
Oh.
Yeah, I noticed not just in here, but I noticed a lot of students checking to make sure the charges were balanced. And then I even caught at least 1 or 2 that's like, that could be a +1 or +2, so I'm going to make that a +1 and put that in parentheses. I'm like, don't do that. Okay. So if I'm giving you the formula, don't get creative on that, please. All right, so how many grams does that equal? The molar mass is, for this is 159, right? 159.61. So multiply the 159 times 1.5 times 3. What is that, 718? Anybody get 718? You did not? Okay. Good, bad? All right, so here's how we're going to write the instructions. Okay? Actually, let me do it over here. So we have our value here of 718 grams. So I'm going to place 718 grams of my copper 2 sulfate, okay? And you can write the formula, you don't have to write the name out. It's actually a very specialized measuring device. It's called a volumetric flask, but you don't need to worry about volumetric flask. Just say in a flask. We'll talk about that in AP. And add enough water, and I'll explain that here in a second. Enough water so that the total volume, what should the total volume be? 3 liters, good. Is 3 liters. Now, here's the reason why, and here's a couple things that we have to have in here. We have to have our mass of what it is that we're making, so in this case 718 grams of copper sulfate. Where did I get that value? From here, from my calculation. And then you have to talk about adding just enough water so that the total volume is 3 liters. Now here's the reason why. If we went and measured out, say, I had my beaker here, and I measured out 718 grams of my copper sulfate, okay? Now let's say that the reading on the flask, and that's a beaker, that's not a flask. Let's say it was 3 liters was right there. Is it okay for me to pour 3 liters of water into that container? And when I do that, the water level will come exactly right to the 3 liter. It won't. Why? Because there's already stuff in there. So the level of the water will be what? Above or below? Above it. So that's one reason why the statement says add enough water. So we don't know if we're going to use all 3 liters of this. We won't. But we don't know exactly how much, so we're just going to keep adding water until it gets exactly to that level. And when it gets to that level, we're good. And then we can be assured that we have exactly 1.5 moles of our copper 2 sulfate for every liter. If I have the water level above the 3 liters, then it's going to be diluted. I'll actually have less moles per liter because I have a higher volume. So make sure that you put in there when doing this statement how much of what it is that we're doing, add enough water, and your total volume is 3 liters. Now, the things that I have underlined are a must. They have to be in there. How you augment that sentence is up to you. Okay? So it's up to you. Yes?
So when you do your calculations, if it's like minus 718 something.
Okay? If it has a decimal, keep the decimal in there if you like. Why didn't I? I was just trying to speed things up. So it's not going to be wrong if you did or didn't. But if you're not sure, then go ahead and put it in there. Okay. All right.